Hey, good morning, everyone. Thanks for coming to the program Taste Fair. This is the FinTech program, and my name is Lingfei Li. I am the FinTech program's admission coordinator. So here is the rundown of today's event. First, I'll just do a very brief introduction. Then Professor Chen will give us a lecture on blockchain and cryptocurrency. If you have any questions, you can type your questions in the chat room. We are going to hold the questions until the Q&A session, okay? So if you have any questions, please feel free to type them in the chat room, and we are going to answer them after the lecture. And then in the end, I will navigate the FinTech program website, okay, just to show you some information about our program, okay. Okay, so for this event, the purpose is really to let students have a quick idea of what FinTech teaching is like at CUHK. So it is really about the experience, okay? And the topic we pick is on blockchain and cryptocurrency. Professor Chen is a professor in all departments, and he's an expert on FinTech, especially on this topic. Okay, so I'm sure he will have a lot to share with you today. Okay, so now I will, without further ado, I will let's welcome Professor Yang to give his lecture on blockchain and cryptocurrency.
Yeah, thank you all very much for coming, and thank you for your nice introduction. So, can you see the screen? Yeah. Now I start my quick talk about the blockchain, cryptocurrency, and also about the stable coins. So, basically, in this short talk, I will talk about what is the value of cryptocurrencies, and what is the relationship to the concept of blockchain, and what is the concept of stablecoin, which is quite popular recently. Okay, so first let's see this data here. So this data, I took it from CoinMarketCap yesterday. So it's about the top 5 popular cryptocurrencies or crypto tokens in the market as of yesterday. So we can see that top 5 includes some very familiar names like Bitcoin, Ethereum, okay? And if you check through the website, we can see that there are currently more than 4,000 different cryptocurrencies and the crypto tokens, more than 4,000. And the total market cap, that is the total market value of all these cryptocurrencies and tokens in terms of US dollar, is as of yesterday, $1.99 trillion US dollars. And so we can check some detailed number here. For instance, for the Bitcoin alone, it has a market cap of more than 1 trillion. So the Bitcoin alone accounts for over half of the total market cap of all these cryptocurrency and tokens. And we can see some other statistics. For instance, if we compare this token market cap to the value at the 2019 year end, the value at 2019 year end was only at 193 billion US dollars. So it's 1/10 of the value today or yesterday. And we can, many of us think that, okay, the cryptocurrencies, they are for investments, right? So we can also compare that to the total market capitalization of US stocks. The value for the US stocks is at 49.11 trillion US dollars. Okay, so that basically says that the total market cap of cryptocurrencies is now 4% of the total cap of US stocks. And others may compare the cryptocurrencies as a fiat money, for instance, compared to US dollars. So in this regard, as of now, the total US dollar in circulation is at 2.14 trillion US dollars. So we can see that the total market cap of all the cryptocurrencies, it almost reaches the total US dollar in circulation. So this will give us a quite good overview about what is the situation about the cryptocurrency market today. And another feature about it, we need to check the price for instance, for the Bitcoin and for the second, the Ethereum. So for this purpose, here is a plot for the Bitcoin price starting from the very beginning before 2015 until yesterday. So we can see that there's some period with a sharp increase, but followed by some periods of decrease, then followed by a volatile period, and until recently there is again a sharp increase. So basically, if we check the past 1 year, from the April of last year to yesterday, we can see that over the past 1 year, the return of Bitcoin is like 693%. Basically, this means that if we had invested $100 into Bitcoin, then by today you will have earned almost $700. Okay, and we can check the figure for the second one, which is Ether. Okay, so we can see very similar patterns. For instance, the return of Ether over the past 1 year is 1,112%. Okay, starting from this point to yesterday. And also we can see that there are periods with downward trends. For instance, if we compare this year, okay, this period here, from this high point to the low point here, actually, if you do the calculation, you can see that the value of Ether had dropped by 90% just within this 1 year period. So this suggests that the risk embedded in the cryptocurrencies is also very high. So next, we will have a very quick polling questions. Just now we have seen the picture here. We find that, okay, if we did the investment in at the right moment, we can hope for a large profit. So this illustrates to us the value of cryptocurrency for doing investment, if we view it as some kind of financial asset for investment. So the first quick polling question is, do you think cryptocurrencies have other values besides investment purpose? Are there any other values? So here I start the polling very quickly. So yeah, please feel free to join. Is yes or no? Okay, I see a lot of all of you have chosen. Most of you have chosen a yes. So yeah. Okay. Yeah. So okay. So 92% of you have chosen yes. So I end the poll now. So yeah, this is quite good to see. Actually, to say it more specifically, it really depends on what type of cryptocurrencies or crypto tokens we are talking about. Okay, as we will see later, some of them will have values other than investment. They will have real values, like the productivity over the blockchain network. Okay, so now let's move back a little bit and talk about why we need a cryptocurrency to begin with. Okay, so the idea is as follows. Yes, first we have cash, the concept of cash in physical form. So they can be viewed as in a decentralized form or peer-to-peer. Okay, because by doing transaction using cash, we just pass on the cash from one person to another person for the transaction. We do not need to go through a central party. And the cash can be viewed as anonymous because we don't have our names on the cash. And then comes a second type, which is called the bank account money. So the most obvious characteristic for it is it's electronic. Okay. However, So from this perspective, it brings us a lot of convenience, because in order to do a large transaction, now we don't need to carry around a lot of cash, which can be heavy for this kind of transaction. We can just bring around our credit card, bank card, or Octopus card, so on and so forth for the transaction. So this is a benefit, a convenience brought by the electronic property of bank account money. However, the bank account money is no longer decentralized. Okay, for the transaction to happen, the transaction needs to go through some central party. Okay, and the degree of anonymity also decreases. So the lack of decentralization may pose some kind of issue, especially the issue of a single point of failure. For instance, what if the central node fails, or the central node get hacked? Okay, so in that case, we will have some usage issue and or significant security issues. So the question is, can we actually combine these two ideas? Can we have a electronic cash which is also decentralized? So can we achieve something like that? A very immediate question is, if we combine these two and get some kind of electronic cash, how can we prevent duplicating the cash? Because compared to the physical cash, the electronic version of cash being electronic is technically much easier to duplicate. And how can we avoid this problem, so-called the double spending problem? So in the following, I will give you a very quick illustration about what the double spending and the duplication problem is. Assuming that we have a three person, Alice, Bob, and Charlie. So as of now, Alice has $2, Bob has $2, and Charlie has $1. Okay, so this is as of now. And assume that now Charlie wants to do buy something from Alice and Bob at the price of $1. So for this purpose, Charlie, for the transaction with Alice, Charlie can send the $1 to Alice, and Alice send the good to Charlie. Okay, so that's normal and simple. But now that we are in a decentralized form, what if Charlie also simultaneously send this $1 to Bob, and Bob also send the good to Charlie? So if we were in a centralized form, so there is a central server, this would not have happened, because once Charlie has sent Alice this $1, the system knows that Charlie can no longer send the same dollar again to Bob. Okay, that's because we have a centralized system. But if this kind of records are stored in a decentralized way, there may be no straightforward way to check out whether the Charlie has sent the same dollar to Alice and to Bob twice. So how can we solve it using the concept of blockchain? Okay, so the idea is as follows. Assuming that in the very beginning, Alice has $3, Bob has $2, and Charlie has $0. So this is recorded in some kind of block. Okay, and here we put A, B, C here to refer to the case that this kind of entries, they are recorded in a anonymous way. So Alice knows that A represents Alice, and this is Bob, this is Charlie. But in the public network, these are just aliases. So each party does not know the real identity of the remaining parties. So assume that then there are some transactions, say A sent $2 to C and B sent $1 to C. And then there are further transactions like C sent $2 to A and A sent $1 to B again. So each block has its fixed size. If the amount of transaction exceeds the capacity of the block, then they will be recorded in a new block instead. So from this chain, we can actually do a very quick calculation and calculate what is the inventory of A, B, C at this stage. And we can just do this by simple adding and subtraction. And we can find that actually today, the amount is exactly given by these three numbers, okay? Just by follow this. So up to now, this is just single so-called chain. But why do we call it decentralized? So actually this chain is not stored in the central server. Instead, it is distributed to the computer of all the participants in the network. Say Alice will have a copy of this, Bob have a copy of this, and Charlie has a copy of this on their own computers. So it's in this sense, this is distributed, okay? It's not centralized. Now, what will happen if Charlie decides to do a double spending? Say as a illustration just now, Charlie as C decide to send $1 to A and $1 to B simultaneously. So if we check the chain in the Alice side and Bob side, we can see two different nodes here and a node here. One says C to A, one says C to B. So in this case, we can see that the whole blockchain system has a disagreement or inconsistency inside. If we view it from the whole blockchain point of view, it's as if starting from one node, now there are two nodes following it, right? So this corresponds, for instance, correspond to C to A, this corresponds to C to B. So there is a disagreement in the network. So how is this issue solved? So this issue is going to be solved in the following sense. So afterwards, the subsequent blocks will be built either following this one or following that one. But after some rounds or some time, one chain will win, okay? In the sense that it will be longer than the other chain. And the key point in the blockchain network is that when doing this kind of a transaction and building blocks, we always follow the longest chain. So if this chain left side chain is much longer than right hand side one, then basically the whole network will agree that the left hand side chain is the real one and discuss the right hand side one. So in this state, we call that the network reaches a consensus. Okay. So and the other situation is, how about some attacker wants to attack the network by changing the history of the network? For instance, the attacker wants to change the transaction within this node, very first node here, block here. So in this case, essentially, the attacker will create a new branch out of the initial block. And again, so the following step is the whole network needs to decide whether this one is real or that one is real. Okay, so this is, and which one is the longest, then the network thinks that, okay, that one is the real chain, and discuss the remaining one. So we can see that the whole procedure can be interpreted intuitively like this. Once there is a inconsistent disagreement, the whole network user will want to vote on each one of them, okay? And the one with the most vote wins. So in this kind of voting process, what is the voting power, or what is the ballot of such kind of voting? So that voting power is so-called proof of work. The thing is, in the blockchain, if we want to create a new block, we need to go through some procedure that requires us to solve some hard problems. By hard, we mean computationally hard, okay? So one example of such kind of hard problem is so-called hash cache, which is actually used by Bitcoin. Here in the following, I just give you a very quick illustration about how it is. So without much technical details. So in this algorithm, Hashcash algorithm, we use a so-called SHA-256 encoder. So this encoder basically transforms strings into hexadecimal strings of length 64. For instance, if the input string is simply the string Bitcoin, okay, then the output after encoding is this string. It is a hexadecimal with length 64. So going in this direction is quite simple. Actually, you can get the result almost instantly. But the hard problem here is as follows. Can you find a string, input string S here, such that in the output string, the first n digits, they are zero, okay? So basically in the output string, it should start with n zeros, followed by an arbitrary hexadecimal string of length 64 minus n. So the problem is, can you find such a string to satisfy this? So of course, the larger the n here is, the more difficult this problem will be. So n here controls the difficulty of the problem. So this kind of problem is has a very important characteristic. This kind of problem is very hard to solve, but they are easy to verify. As long as someone claims that we have a solution, everyone can verify whether it's indeed a solution or not very quickly. So the target for such kind of hard problem is, on average, the whole network should solve one problem every 10 minutes by the whole network's computing power, okay? So if necessary, the difficulty level will be adjusted, but the target is 10 minutes per problem. So it translates to 10 minutes per new block. And so by solving this kind of problem, we need a lot of computational power, right? So if we go back to the story here, what is the voting power, or what is our voting balance? Actually, in this sense, the voting power or voting balance is our computational power, okay? The computer's computational power. And so if an attacker wants to change the history, then when in this voting process, this attacker must win the remaining of the whole network, right? So in this case, if the attacker wants to be successful, then the attacker must have at least 51% of the whole computing power of the whole network. So normally we'll think that, okay, this is very hard to achieve. Therefore, this brings us the level of security for the blockchain network. So by solving, the next question is, what is the reward for those people who are trying to solve these hard problems? Because by solving this problem, they are essentially serving, making service for the blockchain network. So what's the reward? The reward is simply cryptocurrencies on the blockchain, okay? So currently, the reward for the Bitcoin blockchain is 6.25 Bitcoins per block, okay? So by solving one of these hard problems, getting one solution, you get 6.25 Bitcoins, which is not a small amount. And those people who are trying to solve these hard problems and bring that service to the network, they are also referred to as the miners. Okay, so this is the concept of proof of work and how it can solve the duplication and the double spending problem. So there may be one question about the procedure if you want to understand whether there are other values other than investment. So in this whole procedure, we can see that at least using this very simple, very idealized example here, the purpose of the network seems to be only transferring the cryptocurrencies, right? From A to B, from B to C, just for transferring the cryptocurrencies. And by maintaining or serving this kind of blockchain, the reward is again the cryptocurrency. So there is some kind of a circular argument inside. So what is the real value for such kind of cryptocurrency? You may say that, okay, the purpose of cryptocurrency is for servicing the network. But again, the purpose of network is for transferring the cryptocurrency. So what is the value of cryptocurrency again? Okay, so based on a similar idea, in 2013, Vitalik Buterin extended the idea, the Bitcoin network, to create a so-called Ethereum platform. One important difference between the Ethereum platform and the Bitcoin platform is on the Ethereum platform, people can write smart contract. But what is a smart contract? So basically speaking, it is just a computer protocol which is intended to digitally facilitate, verify, or enforce the negotiation or performance of a contract. Basically, you put a contract on the blockchain network. There can be many examples for the application. For instance, it can find application in the supply chain and logistics. Basically, in this, we just put all the entries for the supply chain on the blockchain, from the raw material to the final product. So if anything goes wrong or there's some logistic issues, we can just check the blockchain and find where is the root of the problem. And by the nature of the blockchain, the past record can hardly be modified or tampered with. So this will save us a lot of auditing costs. And other example can include clerk works. For instance, we can put the public notary, import and export of paperwork, and even certain legal accounting documents on the blockchain. And the final type is so-called Erc20 tokens. So in some sense, they are similar to the cryptocurrency on the blockchain in the sense that there are also some kind of coins, but they are not the native cryptocurrency to that blockchain. But they can be viewed as some kind of alternative coins or the derivative of the native cryptocurrency on top of the chain. One thing to point out is that this kind of smart contract, they typically involve quite a lot of calculations or basic operations like plus, multiplication, max, minimum, or the conditional if else, so on and so forth. So each one of these operations will require some computing power to support it because we need to build the new blocks. And as a result, Ether on this top platform, the cryptocurrency is called Ether, okay? So for this kind of purpose, for each one of these transactions, a small amount of Ether is required. So in this sense, at least for the cryptocurrency called Ether, it has some values besides the purpose of investment because Ether can be used to for the purpose of carrying out the smart contract, making sure that they work as intended. So the following is a very quick illustration about how the smart contract can be implemented in practice. So basically, on the Ethereum platform, smart contract can be written in the language so-called Solidity. Okay, the name for the language is called Solidity. You can search it online. And the following is a very basic structure about so-called Erc20 token. So there are some basic functions that the token must have. For instance, we need to be able to get what is the total supply of the token, what is the balance of the token for a specific owner, okay? And we need to be able to transfer token from one address to another address with a certain amount, so on and so forth. So this is a very straightforward illustration about how the Erc20 tokens, they can be implemented in practice using the language of Solidity. Of course, for each of the functions, there will be many details to be filled in, but this provides a very fundamental structure for the function. Okay, so just now we see that by using the idea of smart contract, we can implement a lot of great ideas on the blockchain network. For instance, the Ethereum platform. So now, and the Ether or some kind of token is required to pay for such kind of service provided by the network. So for this kind of token or cryptocurrency, its value can be very volatile, or it can have a period with a sharp increase trend or sharp decrease trend, like the left-hand side figure A, or its value can be much more stable, say in the right-hand side picture B, where the value, although there are some fluctuations here, but it's centered around 1, very close to 1. So for a token, which is intended to be used as a payment method over the network for the service it provided, would you prefer its price to be like in picture A or in picture B? So I will start quickly the second poll here. Would you prefer the price of a token to be like picture A or B if it is to be used as a payment method over the network? Okay. Yeah. So yeah, I see that many of you have chosen the figure B here. So for the sake of time, so I will stop the polling now. So up to now, 87% of you have chosen the picture B here. Okay. Yeah. So the general understanding is agrees with this. So what is the issue with the token that have a characteristic as in the picture A here? What is the issue for it to be used as a payment method? So the issue, intuitively speaking, is as follows. If the market believes that the price of the token will go up, then the user of this kind of service, they are not willing to use the token as a payment method because they would rather hold on to the token for its value to go up, right? They are not willing to spend this token. But if the market believes that there is a downward trend in the value of the token, then the service providers, they will not be willing to accept this token because maybe soon after they receive the token, the value of the token decreases sharply. Okay, so if in summary, if the price of the token is very volatile, this may significantly discourage the use of token as a payment method over the net platform. So this brings us the final idea about stablecoin. The stablecoin, by definition, is a crypto token that keeps a stable market value against some specific index assets, for instance, US dollars. Okay, so stable coins, they're desirable for many reasons. For instance, for the service, they can be used as a settlement method without the need of transferring the tokens into US dollars back and forth. Okay, and also the token can be used by miners or other people who provide the essential service to maintain the blockchain system. Okay, again, without the need of transferring those cryptocurrency to the US dollar or other traditional currencies back and forth. Finally, for those people who are really interested in doing investment in the cryptocurrency, because the value of stablecoin is much more stable, they can be used to form some kind of a crypto money market account, okay, to reduce the level of risk embedded in your portfolio. So next question is, how can we actually create stablecoins? And actually, this problem is referred to as the holy grail of cryptocurrency by many medias. And there are at least 4 existing ways for doing so. So in the following, I just describe them very quickly. The first one is to get a stablecoin, we can ask that it be backed by accounts in a real asset. The idea is as follows. You want $100 worth of a stable coin, right? You just give me $100 and I issue you $100 worth of stable coins. And at a later stage, whenever you want your $100 back. You give me back your tokens, and I give you back your $100. In this way, the value of the tokens can be stable at $1 per token. Okay, for instance. So in this regard, the most famous example is so-called Tether, or USDT. And it claims that it is 100% backed up by US dollar. And actually, the figure on the right-hand side here is a price trajectory of the Tether over the past years. We can see that it's quite stable. And the second example is called DN, and formerly known as Libra. Okay, so in this project, the token is backed up not by one type of asset, but by a basket of very stable financial assets. And there are also tokens that are claimed to be linked to the gold. The second type of achieving a stablecoin is like the work of a central bank. So in practice, if the value of the currency is depreciate, that means the circulation is too high. So the central bank wants to reduce the circulation. Okay, so if the value of currency is too high, then the central bank want to increase the money in circulation. So the same idea can be applied to the token world, token market, okay, to achieve a similar purpose, to stabilize the value. An example of this is Basis. However, this project was shut down in December 2018 because achieving this kind of goal is quite hard, actually. The third type is a so-called issuance by over-collateralization. So the idea is if you want to get $100 worth of stablecoin, instead of depositing $100 US, now you need to deposit $150 worth of the cryptocurrencies on the blockchain. So a benefit of this over the first type is that now you do not need to bring in extra external US dollars into the system, okay? You can just use the existing cryptocurrency in the system. One example of this includes the so-called DAI token issued by MakerDAO. And the last type is so-called central bank-backed stable coins. There are many examples. For instance, the Canadian government did a project Jasper, okay, which is a blockchain network built for domestic interbank payment settlement. And in the US, there's a concept called FedCoin. And in China, there is currently a digital RMB currently undergoing public testing. So what are the potential advantage of a stablecoin issued by the central banks? First, of course, they are legal tenders, okay? And again, compared to the cash, they are cheaper to produce and they will never run out. And they can be checked and taxed automatically by the blockchain technology. And finally, it can significantly facilitate some statistical works, such as GDP calculation and collecting consumer data. Okay, so this is so much for my talk, and thank you for your participation, and thank you for your attention.
Professor Yang, for your illuminating talk. If you have any questions, please type them in the chat room. You can also raise your hand. There is a hand button in Zoom. You can just hit that button to raise your hand, and then I can unmute you for you to ask the question.
And yeah, based on using blockchain for financial inclusion. May I ask what you meant by financial inclusion?
I guess it's about like making financial services more accessible to those people from the poor regions.
Okay, yeah. So currently there, for instance, for the last type, that the central government-backed cryptocurrencies. Actually, there are many countries in the world currently wanting to develop this kind of system, including those some of the so-called third world nations. So if this kind of goal is achieved, then that will greatly facilitate this kind of purpose.
Yeah, I can also give you another example. I think it's related to this. Like, for example, like many people would find it very, very expensive to transfer money to another country, right? Like cross-border transfer. And I think there are some like fintech startups that do these transfers at a very low fee compared with traditional transfer done by banks. And I think they use basically some kind of cryptocurrency to achieve that. Yeah. So you can also view this as kind of something called financial inclusion, because I mean, now the transfer is is much cheaper. Okay, so more people are able to use it.
Yeah, and also yes, the concept of stablecoin is quite relevant to this kind of purpose, right? Because if we want to use that, spend it as a like the fiat money, we do not want to see that its value is very volatile, right? The main purpose of us is the spender is willing to spend this, and the service provider is willing to accept this. If the value is very volatile, then it can defeat such kind of purpose significantly. Yeah, so we, in this sense, stablecoins, they are very relevant for this kind of purpose.
All right. Oh, okay. So there's a further question. Do you see a reduction in momentum of blockchain because pandemic?
You can check the price momentum of Bitcoin during the past 1 year.
I think in general, the public has more trust in Bitcoin nowadays because the U.S. government has just issued so much money during the pandemic, right? So we now have this money flood like this. It's pushing up the prices everywhere, right? We're experiencing actually a pretty high inflation right now. So I would say like people actually have more trust in Bitcoin now because this is decentralized. At least its value is not like you will not depreciate, right?
Yeah, and again, the total supply of Bitcoin, for instance, is controlled, right? That is the pace. Yeah.
So we will end this part now. Thank you very much for your attendance, and then but please don't go. Just give me 2 minutes. I will not, present anything now, but I just want to navigate the website of the FinTech program. Can you see the website now? I have shared the screen with you. Okay. If you can't see it, please let me know. So if you're interested about FinTech, you can visit this website. You can just search for FinTech CUHK. And then you can find this website, and here you can find a lot of things about our program. In the introduction, you can see what FinTech is about, and then you can access some videos here. In particular, this one, why FinTech? So this is a very detailed introduction to FinTech by Professor C.K. Chen. He's a professor of practice in our department, and he's the former Chief Information Officer at HSBC Asia Pacific. And also there are some other videos. Some are from, one is from me about this program admission, and then others are from our students. Okay, and yeah, there's also a video here, okay, created by me for another event at CUHK, which is also about FinTech. So you can take some time to watch these videos if you are interested. And then you can also get lots of information here for the program admissions, study schemes, requirements, and also we post internship statistics here. And overseas exchanges informations here. Okay. I think there are also some statistics here, okay, about where our students have gone on exchange. We also have a dual degree program with Peking University. You are going to get 2 degrees from both universities in 4 years. Okay. And there's a detailed, the detailed information can be found from basically from this link. And you can also find news and events here about this program. And the last part is FAQ. In case you have lots of questions, you can visit this page. For example, like if you're unsure about the career opportunities about of FinTech, you can check this one. So here we explain what are the possible career opportunities for studying FinTech. And if you want to know more about the differences between FinTech and other finance-related subjects, we also have explanations here. And also we have a summary of the attractive features of our program. Okay. So I will stop here now. So if you are interested, I hope you can visit our website to learn more. And in case you have some questions, you can contact us. Okay, so there's a question about does this program require very good math exam results? I would say we put a lot of emphasis on math. If you are a non-Drupal student, let's say you're an IB student, I think we prefer students having higher level math, okay? But we don't require it. If you study standard level math, you can also apply. But if you study higher level math, it's better, okay? And if you are from another background, let's say, for example, like A level, I think we need you to achieve A in your math exam. If you are from JUPAS, typically the middle students would score 5 in their compulsory math or an elective math subject like M1 or M2. All right, I think we need to end this session now. If you don't have any questions, you can leave. But if you have questions, you can stay, and we can stay for another 5 minutes to address your questions.